You know, now that we have jumping in the platformer that we're making to teach you making your first Unreal Engine game, maybe this video finally is going to be a bit of a shorter one. Been promising that since video number 2, haven't I? Today I want to focus on making collectibles, and collectibles come with a couple of different things. We need to be able to pick them up, we need to have some kind of score counter to add them to, and when they are picked up, they need to be destroyed. Couple of fairly basic things, but they are things that need to be programmed in. So let's go into our tutorial folder here and make a new blueprint class. We're going to make this a actor, and the blueprint name is going to be BP pickup. Something just easy and straightforward like that. Now, for the time being, I'm just going to add a cube into this. And a cube is actually just a static mesh component with a default mesh given into it. I still can change this to any other static mesh at any point in our game lifetime if I want to. And we're going to, because probably the next video or otherwise the video after, we're going to dive into Blender and actually make a little collectible model for this thing. For now though, this cube is going to be all there is to it. Aside from the cube, we also want to add a sphere collision to this thing. You can also do a box collision if you really want to. I like just doing things generally as spheres when they're supposed to be things like pickups and that kind of thing. And this sphere collision we set up to be a radius that is a little bit bigger than the actual cube itself. Again, this needs to be fine-tuned when we have the actual assets in place, of course. But this is going to be the overlap trigger. When we overlap with this, that's going to be the thing that triggers us to destroy this thing, add some score, all that type of stuff. So down here, if we go all the way through, you see that we have collision settings. And for a sphere collision, the default is overlap all dynamic. As I alluded to before in one of the first videos, colliders can have one of two, really one of three different interactions with other colliders. Every collider has an object type. So in this case, this thing is marked as being world dynamic. If we just use a custom preset instead of one of the pre-made ones, we can change these. And there's a couple of different object types that you can be. You can be world static, dynamic, you can be a pawn, a physics body, a vehicle, or you can be destructible. You can add your own object types and channels as well. We're not really going to bother with that right now, but that is an option that the engine gives you. So when two things collide with each other, first and foremost, what they do is they check, hey, what type am I and what type are you? So this thing being world dynamic, and we're going to be making this interact with our pawn, is going to check, okay, I'm a world dynamic, you're a pawn, we overlap. That's the interaction that we do. I'm going to not stop you from colliding with me, but I'm going to trigger a signal that says, hey, I've just been overlapped with. And it does that in this case because we worked off of the overlap all dynamic. It's going to respond with everything to overlapping. If we set it to blocking, it's not going to trigger an overlap event. What it's going to do instead is it's just going to any object that is of any specific type that we make it respond to that way, is going to just, well, do collision as you would expect collision to work, just like a wall, an invisible wall. Or it actually is visible, a visible wall, I guess. Since this is a trigger sphere, what we're going to want to do is, for the most part, I actually want this to ignore everything. I don't want this to trigger when we run into this with a world static or another world dynamic or whatever. I only want this to overlap if specifically a pawn interacts with this. Any other type of object we can just safely ignore. Now, on the other hand, the player also needs to not be ignoring the world dynamic type, because if either party ignores the other, there's just not a collision event at all. So they both need to at least be set to overlap for that to happen. Then we also need to make sure that generate overlap events is on. If this is off, this collider is not going to really do anything at this point. Generate overlap events is necessary for this actor begin overlap to actually fire off. So let's make sure that I have that enabled. Actor begin overlap is an event that triggers whenever any of the colliders on an actor are overlapped with in whatever collision setting way that they have specified for themselves. So if I have 2, 3, 5, 15, 32 different colliders on this actor, overlapping with any given single one of them is going to trigger this specific event. There's also component-specific overlap events. So if we just scroll down a little bit on the details panel here, we can see that we have an on-component hit. That is when blocking collision happens. But we also have a on-component begin and also end overlap. The actor also has an end overlap version as well. Don't really care about that for what we're doing right now, but it's interesting. So you can add a component overlap instead. And that way, if you have multiple different components and you want specific code to trigger when a specific component is overlapped with, or when it is hit, you can do these component-specific ones instead, which gives you a bit more information as well. It tells you which component was overlapped with, so it just gives a reference to this component in this case. It tells you which actor overlapped with it, which components from that actor overlapped with it, and then some sweeping stuff that we don't really care about. So that's just good to know that it exists. For now, what we're going to do is we're just going to stick with actor begin overlap. Here, we can check what the other actor is. So which actor overlapped with our trigger. We want to check whether or not that is the player. We can do that in a handful of different ways. We can use the cast to BP player character that we made before. Because as we discussed, if this object that's overlapping with it is this player, our code will execute through this pin. If it is any other actor, being an NPC that we program in the future, or any other hazard that just happens to clip through the collision for this thing, this cast will fail and it'll just stop executing, or we can like print string to warn, hey, something weird is happening here, look at that. This is one way to do it, and it's honestly like not a bad way to do it either. An alternative would potentially be using the isAsoft node. This pretty much does something similar to casting, except it is a bit more memory friendly. In a quick overview, casting something means that it's going to be always loaded into your computer's memory, even if it doesn't necessarily need to be. Obviously, if we're casting to the player character, that doesn't matter, because it's gonna be in your computer's memory anyway, because the player character needs to exist to play the game. But if you're trying to check this overlap against an entirely different type of actor that might not already exist in the world, casting it means that you're going to forcefully load it into your computer's memory while it doesn't need to be. That's where this comes in. This is effectively a check of, hey, is it this type of blueprint without it loading it into your computer's memory? That's what a soft reference does. You can get a reference to a class, BP player character, something like that. There we go. And we just get this true or false without it loading that thing into memory. So this is just a little bit more optimized in scenarios where you're not sure the thing that you're comparing it to already exists and already is loaded. If it is already loaded, it's not a big deal to just use casting. Third option is just doing a comparison. We can check, hey, is this actor that we're pointing to the same as get player character? Get player character just gets you a reference to the currently possessed player character. Now, if you're working with multiplayer games, not to say online multiplayer games, I mean like couch co-op type of games, you might have multiple characters being controlled by multiple people. So that's where this player index comes in. If you have 4 different people playing, the player indexes for those would be 0, 1, 2, and 3. So for a co-op game, this wouldn't work that well because this is only checking if this is player 0. And if player 1 overlaps with it, it's not going to work that well. But if you're just making a single player game, this is a super useful little shortcut that just gets you a reference to the player character. And even if you're making an online multiplayer game, as long as it's just one local player, this just gets you the local player. Super useful little thing. So we can check, hey, does this reference point at the same actor in the world as this reference? That's what this node does. And if it does, that's another way of checking whether or not we're overlapped with the player or not. I'm going to keep it at this because we're making a single player game that doesn't need any like secondary players to go with it or whatever. And this way it is not coupled to specifically that blueprint class. If at any point I decide I want to remake my player blueprint and whatever, I don't then have to go back into this blueprint and change the cast that I'm doing or something like that. So then we only need to do 2 simple things, right? We need to add score to the player and we need to destroy this pickup. Adding score can be done in a handful of different ways. The most easy and straightforward of which would of course just being opening up our player blueprint. making a variable here for the score and increasing that. And that works, and that's how a lot of games do it, and that's how I personally do a lot of stuff in my own game. There's a lot of different ways that you could go about doing this. I like, for now, doing it with a game instance. As soon as we move over to starting to talk about save data generally is the easier way to keep track of this, but that also still relies on your game instance. So we're going to be setting up a game instance is pretty much what we're getting at here. So open up a new blueprint class that we're going to be making, and we're going to be making a game instance. Game instance type, and this will be GI for game instance tutorial game. And this is an object that doesn't exist within a world. It exists above the hierarchy of a singular world in the game. This is actually the object that the entire game technically exists within. So if you go from one level to another, that all happens somewhere in the game instance. So the game instance never gets refreshed, never gets reset, which can be a downside because it's hard to reset information inside the game instance if you need to reset it. For instance, if you save a game and then load up another game, any data in here would need to be manually overwritten. So that's why eventually what we're going to do is this game instance is going to handle save objects that are actually going to be holding the data. For the time being though, we're just going to put the information directly on the game instance just to show you. So we'll make a variable for the player's score, and then that's going to be an integer. Make sure that we just spell everything properly. And that's really everything we need to do here. We can make custom events just like we can everywhere else. We'll call things add score, maybe. All that is going to do is it's going to set our score to our score plus some value. And the value that is going to take in is, well, the thing that this event is going to take in. If you just drag over any of these lines into a custom event, it becomes an input for said event, which is nice. Clicking on the event itself, we can give it a name, something like score to add. And now anytime we have a reference of the proper type to our game instance, we can call the add score function, which will now take in an integer as an input. So whatever we put into here is going to come out of here and be used in this little bit of code. Setting up your game instance takes a little bit more work though, because you need to go into Edit, Project Settings, and then you need to just type in game instance, and this takes in your game instance class. This is something that you preset up in your project. You don't dynamically change this out during gameplay. And frankly, a project having more than one game instance class is kind of worthless because it's not going to be changing. You can only set it on a project-wide level. So we're going to set it to our tutorial game instance. Then it is time to go back into our pickups. I've actually put a couple of them down in the world here just to prepare them. And if our overlapping code succeeds and all that kind of stuff, we get the game instance, which is fairly similar to just get the player character. Instead, it gets a reference to the game instance as a whole. It gets a generic game instance reference though. So our add score doesn't work, doesn't exist. We need to cast to our GI tutorial game, and that gets us our upgraded tutorial game reference. At which point we can add score, just smoothly and easily like that. This takes in a value. We're going to pull off of this and promote that to a variable. It's automatically going to be called score to add because that's the name of this input, which is quite nice. And now we're going to do something that we haven't done before, and that is we have a variable. If we click on this little eyeball icon over here, or alternatively in the details panel, the instance editable checkbox, it becomes, well, instance editable. It becomes exposed. And that means that if we go back into the level and we click on any instance of this blueprint, which we can just drag in like this, we have a little field here that we can populate with whatever value we want. So let's say that this one gives us 2 points, this one gives us 5 points, this one gives us 1 point, and this one gives us 22, something like that. Now we have one blueprint that executes the same code, but with different values depending on which actual in-world object we interact with, which is really quite nice. And now we start getting into what really makes proper architected, object-oriented code so powerful. Because now instead of this just being an integer, imagine this being a door. and a door that needs a specific enemy to be killed to open. We can make that door something generic with an exposed variable that says, hey, when this enemy that we're referencing dies, then you open. Then you can put that door into your level, and on a per door basis, you can link it to different enemies. So here you start really like building up the potential for making these objects flexible and powerful to help you in designing your levels. Now, in my player character, what I'm gonna do is I'm just gonna real quick add in the tick event, because I just need a way to print out our score to show you. So game instance, cast to the GI instance thingy majig, and then we get the score out of that, and we will print string here. Just as easy as that. I'm going to open up this print string node, which you can do just by like uncollapsing it and giving it a key. I'm just going to give this the key score. And a print string node with a key will replace any previously made strings with that same key. So that way it's not going to spam our entire screen full. It's just going to have one little thing going over and over and over again. And here we'll be able to see if I have 0 points in the top left corner right now. If I overlap with this one, I get 1 point, and it doesn't destroy because I haven't added that node yet. We'll do that in a moment. If I overlap with this, I get to 6 points because it's +5. This one gives 2 points, I believe, so it should get me to 8. And this one gives 22, so that gets me to 30. And just like that, all that works. Now, the pickup itself needs to be destroyed when we pick it up as well. That's just a matter of adding in a very easy destroy actor node. It's really not that like exciting. Now it just destroys the actors as that code runs. Just that simple. Now, one last thing is I want to show you why this matters. Why are we using the game instance, right? So what I'm also going to do is I'm going to, in the pickup, as just a little bit of temporary code, I'm going to add to a variable on the player character. So we cast to our player character, and I'll also add a player score here. So player score should also be an integer. And I'm not going to make an event for this, all that kind of stuff. All that I'm going to do is I'm going to set player score to player score plus our score to add, which is also a good thing to be aware of that you can do, is you don't need the object itself. This blueprint itself doesn't need to be the one responsible for setting values on it. As long as you have a reference to it, you can very much run anything that this thing has, more or less. We'll get into the nuances of that a little later. The same way that this object could run it by itself. I could even make this guy jump. It's just a function that exists. It's an event on that blueprint. And if the blueprint itself can call it, 9 times out of 10, as long as you have a reference to it of the proper type, you can also call it from other places, which includes setting the value for variables. So we can get our current score. That said, generally, it is good practice in most cases to make objects responsible for their own data and not be set from all kinds of external places, but it is a possibility that you can do. So the whole reason that I'm doing this, by the way, if you are wondering, is because I'm going to be printing out the score for the player just in a different color real quick. So let's make that like purplish. And that will be a print string. And you will see when I reload the level, this player score will get reset because the player doesn't travel to a new level. What happens is we go to a new level where we have a new player character, which we possess. But it's an entirely default blank new player character. Whereas the game instance remains. It doesn't get reset. So this one will keep its score. This one will get reset to 0. For that, I do need to really quickly add in a way for me to open a new level, though. So what we're going to do is I just add a debug key for O. Debug keys are just quick little events that you can point to, which aren't abstracted like the way that we did with the input events and all that kind of stuff. They also only work in development builds. If you actually ship your game, everything that has this development only label on it is just going to get stripped out. So these events will too. But we can just open level by object reference, and the level I will open is the level that we just have here, which is level third person. just as a quick little demonstration. So you can see everything counts up exactly the same way, but then when I open this level again, the 30 from the game instance still exists, but the player got reset. And you can see that the objectives or the pickups or whatever you want to call them have respawned because the level as a whole has reloaded. And we just keep counting up in the game instance version of it. And then I reopen it again and the player version of it resets. That's why you want to, if you can at all help it, not store your stuff directly on the player. Or at least if you do that, when you open a level, you need to first write it to some place that it's safe, like a save object, and then load it back in on begin play. We'll talk a little bit more about that when we actually get to saving data and actually traveling between some different levels. And then there's also level streaming that we're going to be looking at. So there's a couple of different aspects to this that we need to discuss. For now though, we've got a little pickup, and I think we've done so much to do with understanding programming and setting up our first bits of code and doing quite a bit of honestly pretty dry stuff with animation blueprints and all that kind of stuff. I think next time what we should do is we should open up Blender and get started making just a little like diamond or something that we can put in here. Because that'll also allow us to get started with some basic materials, which is going to be fun. And a very big thank you to all my Patreons. You can see them on screen right now. If you want to help support the channel or get any of the project files in any of my tutorials, there's a link down below to the Patreon page to support me, or alternatively as a YouTube member. My Cave Students tier supporters, Oiku, Earl, Monseville Erno, and my Cave Digger tier supporters, Mauricio Farias and Chang the Dude.